Hello, y'all. Um, we're going to do a quiz review for your corrections that you should have done today or yesterday in class. We have a test this week. Set up office hours with me if you feel like you're not going to do well, or watch these videos. Cool. So, having an understanding of conservation of energy suggests that if a boulder at rest on top of a hill has 1,000 joules of potential energy, then the kinetic energy when it reaches the bottom will have blank. Assume frictionless surface. So, I wonder if I could make this a bigger page. Okay, never mind. Okay, I'll just draw it, whatever. So, if there's a boulder right here and it's going down, right? Here, it has 1,000 joules of potential energy. And if it's not moving, it's 0 joules of kinetic energy, right? And because of the law of the conservation of energy or something, I don't know. No energy is created or destroyed. So there needs to be, at the end, 1,000 joules of energy, like a certain combination of it. So, because at the end, we're like moving, and all the potential energy has been like used in the transition from going down the hill. So it'd be 1,000 joules of kinetic energy and 0 joules of potential energy. So then it'd be like this. All right, let's move on. Okay, if a snowboarder's mass is 100 kilograms, what is the PE at the top of the hill? If the mass is 100 kilograms, and the formula, if we look at our one-stop shop, is mgh. And if we're at the top of the hill here, it tells us that it's 4 meters. So we have mgh is equal to PE. Our mass is 100 kilograms. Our gravity from our one-stop shop is 9.8. And our height is 4 meters. So then you multiply all those. Let me see. 100 times 9.8 times 4. So then you would get 3,920 joules. And that's right there. Let's move on. This one's kind of hard, so we'll come back to that one. What unit do we use for power? Let's look at our one-stop shop. And we use watts. That's that. Mechanical energy is considered a blank. Okay. Mechanical energy is made up of kinetic energy and potential energy. And that's not me, it's mechanical energy. Okay? So, with this word, scalar, there's scalars and vectors, right? Vectors have a direction. Scalars do not have a direction. Does energy have a direction? When you get shocked by one of those like fake gum, like y'all know what I'm talking about, the gum that shocks you when you pull it? Like when that shocks you, does that have a direction or does it hit you from everywhere? You know? Or when you're driving a car. Okay, forget about the driving a car. It has no direction. So, it's going to be a scalar. Because it cannot be a kinetic. And it cannot be a potential because that doesn't mean anything without the words energy at the end. And they are a part of mechanical energy, but they are not equal to. Okay? Oh my. With the same understanding of conservation of energy. Actually, let me end it here and then I'll do a part 2.